In example 10, you're asked to interpret the given position time graphs and describe how an object would move to produce the given graph. So if you haven't already done so, you should write down in words right underneath each of the graphs, like here and here and here and so forth, what the object is doing to produce the given graph. Okay, assuming that you've already done that, let's take a look at 10a. You can see we have a horizontal line here, and let's put some numbers here. Let's write this as 1, 2, 3, 4, and 5. In this particular case, his position is not changing, if this was the moving man, for example. So this is an object that is remaining stationary. So you should have something like this written down. Let's take a look at now B. I've added a scale to my picture so I can be a little bit more specific. And here at time 0, our object is starting at an initial position of 2 meters and then has a nice straight line in here, which indicates that the slope is constant and therefore you have a constant velocity. So this is an object starting at 2 meters and moving away at constant velocity. Okay, so you should have hopefully something like that. Let's move on to C now. And again, I'm going to put numbers over here. In this example, the object starting at an initial position of 1 meter, and then you can see it's curving. So that means the object is accelerating. And if this is in the shape of a parabola, then we could say that this object is accelerating at a uniform rate. So this is an object speeding up in the positive direction, starting at 1 meter. And there I've written down what I've just said. So let's go on to D here now. In D, we have an object starting at roughly about 2 meters here, and is moving upwards and eventually gets to the top of the path and slows down to a halt here and then comes back down and overshoots for the place where it started at and actually ends up lower than it was. In this case, we have a negative acceleration. All right, so I've written something probably not fully detailed here, but hopefully you get the idea. I know that the velocity is away because it's positive here and it gets up the top. Remember, I'm drawing tangent lines for our velocity here. At the very top, the velocity is 0 here. And then as it comes back down, the velocity is now becoming more and more negative. So if you could use your little ruler and draw tangent lines along here, it can give you an idea what's happening to the velocity versus time graph as well. Okay, let's go on to E here. We have an object that is starting off, here's 1, 2, 3, so about 3 meters here. And then it is moving in towards the origin, but as you can see, the slope is becoming less and less negative, and eventually here the slope is 0. So here I started with 3 meters and then moving in the negative direction. It slows down eventually to a speed of 0, and all along through here we have a positive acceleration. To demonstrate this motion, I'll just use our moving man animation to show you another picture of this. There you go, and he's slowing down and coming to a halt right about there. So you can see that's the curve that we were looking for around there. The velocity time graph would look like this, and the acceleration time graph would look like that. And back to now F, we have this kind of graph, and this is the one that I talked about in the previous video. This is very tricky, you won't see this until later on. This is oscillatory motion. This is actually in the shape of a cosine curve. So the object exhibits simple harmonic motion. It oscillates back and forth between these positions, so if it would continue, it would go on forever.